Okay, hey guys, I'm going to be talking still about FP2, about the method of differences this episode. Method of differences is a clever way of adding up a sum where terms sort of cancel each other out as you go along. And I really like this because it means you get to cross out a lot of your work and it's just quite fun, I think. So the question I'm going to be talking about is Jan13, so January 13, question 3. So if you want to make sure you have that open in front of you like I will, I'm not going to write out every question, I'll just talk about, A, B or C, so just have them open in front of you so you can look at them. So part A then is a show that question. We need to show that 1 over 5r take away 2 minus 1 over 5r plus 3 is equal to a, and that's a constant that we need to find, a over 5r minus 2 times 5r plus 3. Okay, we're going to start with the left-hand side here, and we need to work our way over to the right-hand side, saying what a is at the end. So start off then this proof, starting with left-hand side equals. Yeah, I think this is the best way to do it. And what I'm going to do is I'm going to make the denominator of the left-hand side equal to the denominator that we know we're going to have to end up with. And in order to do that, I'm going to have to multiply this fraction by 5r plus 3 and multiply this fraction by 5r minus 2. So let's do that. So we'll have 5r plus 3 over 5r minus 2 times 5r plus 3. And that would be take away 5r minus 2 over 5r plus 3 times 5r minus 2. So now we have two fractions and the denominators are the same, so we can combine those fractions. My numerator, I have 5r take away 5r, that gives me no lots of r, plus 3 take away negative 2. So that gives me 5 for the numerator, so a is going to be equal to 5, and my denominator is exactly what they wanted. So that's right, with a is equal to 5, and that's the first 2 marks of that question. Not too bad there. Yeah, I can see the lights reflecting here a little bit. I might just tell myself to avoid that in the future, so avoid that area there. Cool, okay, so let's go on to part B then, and we're going to use part A to help us because of the hence show that this is true. So we know we're going to have to use part A to help us out. So we want to find the sum to n of what we were given in part A. So we need to find the sum from r equals 1 to n of 1 over 5r minus 2 times 5r plus 3. Now, I know that I need to use part A to help me because of the hence, so I'm going to rewrite this fraction as a fraction that I found in part A. It doesn't quite work though because the fraction in part A had a 5 up here. So in order to make this work, in order to use part A, well, I want the sum from r equals 1 of n of 5 lots of 5r minus 2. Because this is what fraction I know the value of using part A. Using part A, I know I can split this fraction up into 2 different fractions. However, this does not quite equal this because I've changed the numerator. I've changed the numerator from 1 to 5. So to make sure both of these things are equal, I need to include a 1/5 outside of my summation sign. And I'm going to have to remember at the end of the question, if I just focus on this, I have to remember at the end of the question to multiply back by that 1/5. And that's where lots of people make errors here. They sort of do this, they get the factor of 5, but they forget at the end that they need to multiply by 1/5. So if you have an answer that's 5 times the answer that you see in the answer book, that's why. Okay, so using part A now, we can rewrite this bit as, so remembering the 1/5 here, that's 1/5 times the sum of r equals 1 to n, and then as I said, this fraction we know from part A, that's 1 over 5r minus 2 minus 1 over 5r plus 3. Now the reason why people forget about this, this 1/5 is because in order to do this method of differences, we just look now at these two fractions within a summation sign. We list these two fractions for r equals 1, r equals 2, r equals 3, and all the way up to r equals n. And hopefully we should get some of them cancelling out with each other, and that is what the method of differences is. So I'm going to find out what this is, or really I'm going to find out what this is. So remember, I'm leaving the 1/5 to the end now. So I'm just looking at everything but the 1/5. So our first term then is going to be when r equals 1. So when r equals 1, we have 1 over, and I actually don't work out what these numbers are because they all sort of cancel each other out anyway. It's a bit of a waste of time, I think. Might not be the case in this question here. We'll see what happens. So that's 1 over 5 times 1 minus 2 minus 1 over 5 times 1 plus 3. In fact, I think I might be writing the numbers out in a second. Let's have a look at r equals 2. So the first fraction here is 1 over 5 times 2 minus 2. And the second fraction here would be 1 over 5 times 2 plus 3. Now at the moment it doesn't look like anything multiplies out. That's because I've been lazy and I've left my numbers like this. Sometimes it works out. I don't think it has done. Here. Because what we have is 5 times 1 plus 3 will be 8. 5 times 2 minus 2 will be 8. These two fractions will be the same and will cancel out with each other. I need to make that clear though, so I am actually going to write in what my denominators are. So going back for a second then, 5 times 1 minus 2 would be 3, so that fraction's a third. 5 times 1 plus 3, like I said, that's an eighth. This one is an eighth as well, and this one would have been 5 times 2 plus 3, which is 13. I recommend probably going up to r equals 3 just to see the pattern. 5 times 3 minus 2 is 1 over 13. That's going to cancel out with this 1 over 13 here. 5 times 3 plus 3, that's minus 1 over 18. Then what we do is we miss a few out because we've got a sense of the pattern now. We know that this one's going to cross out with this one's going to cancel out with this one. I need to know what happens at the end now. I might bring my camera down a little bit for this. Give myself a bit more space there. You're not going to be able to see my head, but I don't think you'll mind, will you, for a few minutes? Might even be nice. Okay, so the last two terms then, when r equals n minus 1. So I've put dot 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 here because I've left some gaps here. Just jumping now to the second to last term. N is the last term, so the second to last term would be r equals n minus 1. So that'd be 1 over 5 lots of n minus 1, take 2, minus 1 over 5 lots of n minus 1 plus 3. That's my second to last term. And then my last term, r equals n, 1 over 5n minus 2, and minus 1 over 5n plus 3. Hopefully just on the screen, yeah, no worries. Okay, so now I get to do the fun bit. I get to cross out my work, cross out the stuff that cancels out each other. So minus 1/8, that cancels out with 1/8. Minus 1/13, that cancels out with 1/13. Minus 1 over 18 will cancel out with whatever's here. And then this will get cancelled out with whatever's sort of before it here. And this will cancel out with this. So everything is cancelled out except for my very first part of my first term and the last part of my last term. So inside the summation will be a third take away 1 over 5n plus 3. But remember, I have to multiply it by that 1/5. Have to multiply that by the 1/5. So make sure you've got that written down because I'm going to rub it off now. So this summation, or now I'm going to write out what the whole line equals. So the whole line is 1/5 multiplied by the summation is equal to 1/5 multiplied by a third take away 1 over 5n plus 3. So that's what we've got as an answer, and now we just need to give it in the form that they've asked for in the question. So I look at the question now and I think, what's different from the answer in the question to my answer? The answer in the question is all one fraction. I've got 2 fractions here. Hang on, that can't be right. I'm going to have to go from 2 fractions to 1 fraction. How do I do that? Well, I make sure they both have the same denominator. Can't think of any nice lowest common multiple. So I'll just multiply this fraction by 5n plus 3 and I'll multiply this fraction by 3. So this equals the important 1/5, don't forget that. So that'll be 5n plus 3 divided by 3. Take away 3 over, 3 lots of 5n plus 3. Minus 3 over 3 lots of 5n plus 3. I've got the 3 lots of 5n plus 3 on my denominator. That's great because that's what I wanted. The 3 cancels out with the minus 3 here. So I've got 1/5 times 5n over 3 lots of 5n plus 3. And then the 1/5 cancels out with the 5n to give us the answer that we wanted, n over 3 lots of 5n plus 3. Cool, and that was 4 marks. Pretty good for 4 marks, not too bad. Remember the 5th. That's the biggest place I think where people could go wrong now, remembering the 5th. Cool, alright. I'm going to have a look at the last question. I'll just rub the board off quickly, then I'll have a look at the last question. So 1 marker, so I reckon it'll be pretty quick. One of these sum to infinities. Okay. Right, I'll bring the camera back up. You guys will be able to see my face again. Lucky you. There we go. Okay, so now we want to find the sum from r equals 1 to infinity of 1 over 5r minus 2, 5r plus 3. So we want to find that. Now there isn't a hence, it doesn't say hence find the value of, but we are going to be using the previous question. We know that this sum, when it's a sum from 1 to n, so we know that from r equals 1 to n of this stuff, I'm not writing that out, okay. We know the sum from r equals 1 to n of that stuff is equal to n over 3 times 5n plus 3. Okay, so that we know that when this is an n here, the formula is going to give us n over 3 times 5n plus 3. However, we don't want this when this is n, we want it when n is equal to infinity. So what we need to do is what's called finding the limit of this when n tends to infinity. So we're going to say as n approaches infinity, as n tends to infinity, it's written with that arrow there, as n tends to infinity, let's have a look at this fraction here. What's going to happen to this fraction here? Well, if I expand out the bottom, I've got n over 15n plus 3. Now, when n goes to infinity, what we're going to have is infinity over 15 lots of infinity. The plus 3 doesn't make any difference because the numbers are so large at this stage. Adding 3 onto infinity or 15 lots of infinity doesn't really affect things. But what we can say is infinity over 15 lots of infinity, that does have a limit, and that limit is 1 over 15. Something that's incredibly large divided by 15 lots of that same number will be 1 over 15. It's okay if n approaches to infinity, we can still find that as a limit. So the answer to the last question then is 1 over 15. Don't have to say too much to get that 1 mark, I would have thought, because it's only 1 mark. Okay, as always, any questions, any comments, anything like that, email them to me or put them in the little comments box in YouTube there. And yeah, I'll see you next time. Best of luck, guys.